Hi everyone, this is Sean Ismail from the Cloud Ranger. You're viewing the Microsoft Azure training. Today is the part 7 of our Azure Virtual Machines, and we're going to talk about virtual machines networking, specifically virtual machine endpoints and load balancer. This networking is not about VNets or networking in Azure. We have covered that in details in previous sessions, but this is about networking that's related to the virtual machine directly, which is not on the VNet. So let's get started. So this picture should be a little bit familiar by now to everybody. This is a user who's trying to access two virtual machines or one of the virtual machines, and you can see that it's going through a cloud service to get to these virtual machines. Stuff that we already know is that virtual machines are always they are always created within a cloud service or domain name. That's what the cloud services are called right now. So what will happen is that you can have multiple virtual machines or a single virtual machines with a one-to-many relationship. So a cloud service could have one or many virtual machines. And we will see why this was important today. And the way you access this cloud service would be with a VIP, which is a virtual IP, or the public IP address. And this public IP address will have port translations that will be done to these both virtual machines. So this is how it sort of works over here. You have a user who's trying to go to this virtual machine or the services on these virtual machines. It'll go through the DNS, for example, with the cloud service name web app service 100.cloudapp.net. We know that all cloud services will have a webapp.net domain name. Okay. So what happens is that once it goes and hits the cloud service here, it then figures out based on the ports that where it needs to go to. So for example, if the user goes to web service 100.cloudapp.net, there's a port X. So which is pretty much the VIP going to the port X, right? Because this is the VIP. That port X will take you to web app 100. So similarly, the only reason they'll go to this VM, web app 200 over here, the only way you could go there is that if this user actually refers to this cloud service with a different port number. So it's the same IP address with a different port number that pretty much decides that which one you'll end up going to. Now, the way we can define these port numbers here or how it will go to is by defining something called as endpoints. And endpoints are basically like they're simple port forwarding, right? From an external port on a single VM, port to a virtual port on a single VM. So when you come to the cloud service over here, you look at a specific port. So for example, port X, it'll look at that port X and it will know that if I ever come to port X, what I need to do is go to a different port or go to a port on this virtual machine. Okay, so it's basically a port forwarding at this cloud service point. And what happens over here is that we keep saying cloud service, but in that cloud service, there is an appliance or there's some sort of a system where we are telling it to go and do the port forwarding. But Azure makes that totally transparent to us, and all we know about that is that, hey, we went to the virtual machine and we opened up an endpoint. So if we are trying to RDP to, for example, web app 100, the public IP address will have an IP address that will forward us to port 3389, which is on the virtual machine. We can't have port 3389 on the cloud service here because then when this user comes in and it goes to the VIP and port 3389, it will not know that should I go to port 3389 on web app 100 or should I go to port 3389 on web app 200. You could change the standard port for RDP on these two VMs, but that would be too complicated. So what Azure has decided to do is say that, okay, the cloud service will have a random IP address, okay? That random IP address will be forwarded to port 3389. And this random IP address on this cloud service will be unique for these two virtual machines. So this will probably make more sense when we are going to do more demos, but for now, we have to understand that the endpoints on these virtual machines decide that what will be allowed to come in here and how this port will be forwarded to come in here. as well. And just remember for now that there is an appliance or some sort of a system or some sort of a virtual appliance on the cloud service that deals with that port forwarding. It's not just magic. And the and part of this whole load balancing that we'll be talking later also happens in this cloud service area. And we have to remember that your endpoints can also be configured to allow that load balance traffic to come in. Okay, so we are going to jump in some sort of a demo over here, and I'm going to show you what I mean. Okay, I'm at my client system, logged into my subscription. As you can see my screen here, I have two virtual machines that have been created, Ranger VM 001 and Ranger VM 002. What I have done is that I have put these two virtual machines in the same cloud service. And you can see that from here, the DNS name rangerweb.cloudapp.net, rangerweb.cloudapp.net. So we can see that these both are the same cloud services. You can see that from here as well, Ranger Web. And what happens is that this cloud service right now is holding both the virtual machines, and this is what's all the port numbers and everything that are on the virtual machines. So rather than going over here, let's go to the virtual machine, and I'm going to show you the endpoints real quick. So if I go to Ranger VM 001, and you know that by default, there are two endpoints that will always be created, the one for remote desktop and the one for PowerShell. Same with Ranger VM2, you can see the endpoints, there are two already created. And the way what we have we have done here, or Azure has done here when they were provisioning this virtual machine, you can see is that there's a public port and there's a private port. So on the cloud service, we have said that for remote desktop, use 63031. If someone hits the VIP or hits the cloud service and asks for port 63031, forward it to 3389. And in Ranger VM2, as you can see, we have made the public port 55148. Like I said, this public port needs to be unique. But again, on the virtual machine, we do not care because these are two separate virtual machines. It's coming to 3389. Okay, so if you go to the slide over here, this is where the unique IP addresses are, and they're forwarding to both 3389. And the way we are allowing this port forwarding is by defining the endpoints. And with the endpoints, if you do not define the endpoints, you cannot send traffic here, right? So if somebody wants to go to, for example, web app 100 and tries to hit the web server, which would be port 80, just because we do not have port 80 defined over here, right now, if somebody tries to go to the web browser and put that web app, whatever the DNS name was to go to the port 80, it's not going to work because there's no port defined over here. So that's what we mean by defining an endpoint. And obviously there are operations that you can do on this for creating, the way you would add an endpoint is basically just come add over here. We'll add a standalone endpoint. So you go to standalone endpoint and you define your endpoint for the virtual machine here. So Azure has some of the most standard virtual machine endpoints already defined. So for example, if you want to go to HTTP, you come to HTTP. The protocol is TCP. We are saying port 80, port 80. We are going to leave everything the way it is. We hit OK over here, and you'll see that Azure will create an endpoint for HTTP over here, which means now that the Ranger VM 001 VM can accept anything on port 80. Okay, and in this one we have kept it standard. Means if somebody goes to the web, the VIP or the cloud service and goes to the browser, it will hit port 80 on Ranger VM 001. Ranger VM 002 does not have port 80 and it's not going to work. Okay, let's come over here and I'm going to introduce my next topic by actually trying to put port 80 in here to demonstrate something. Did you notice something? As soon as I tried to put port HTTP, I started getting an error. The error is that the public port and protocol conflict with another endpoint in the current deployment. Another endpoint. Well, I do not have another port 80 over here. Why am I having that problem? Well, the reason I'm having problem adding port 80 on Ranger VM 001 is because the public port 80 is already taken and they both happen to be on the same cloud service. So on the same cloud service, you cannot have say similar public port endpoints created for two separate virtual machines. Because this is where the conflict starts by design. If I have port 80 defined on this cloud service and this user is trying to hit port 80 on this cloud service, it will basically not know, should I forward that port 80 to VM1 or should I forward it to VM2? Because there's no way for it to understand to send this over here or here. Okay? And this is by design. And this perfectly makes sense. When we were doing the RDP, we were telling them 63031. We knew that this is a non-standard port. We knew that this is a not standard port. So you'll be like, okay, so Sean, if I try to RDP to Ranger VM001 from my home PC right now, what will happen? Well, if you did the RDP before and you studied the RDP package, let's do a connect. You'll see that Microsoft puts that information for you in there. So it does not become like some sort of a nuisance for you. But if you try to do a regular RDP and do it by yourself, obviously there would be a problem. So this is the one we just downloaded over here, okay? So if we go and do an edit, you will see that we are on Ranger Web, which is the public VIP or the web service, cloud service, I mean. It's trying to connect to port 63031. It's not connecting to 3389, okay? The reason it's going to 6306, what was it? 63031 is because of these endpoints that are defined over here, 63061. So this is the only way we can forward this now to 3389. So when this tries to connect, it forwards this to 3389, okay? If you went and tried to create, I mean, you don't need the RDP, right? I mean, you're like, okay, I'll do this myself. I don't need like this. I'll just go and delete this and I'll try to connect. What will happen? Well, if you do not put a port number in the remote desktop connection, by default, it knows I'm trying to hit 3389, and you will probably not hit anything. It will time out because it goes to the cloud service and it asks him that where do I go? And the cloud service says, hey, I do not have anything on public port 3389, so I do not know where to forward you, so it will eventually time out. So to make this unique on the RDP point of view, the Microsoft Azure has done this because they know that chances are you're going to come over here and hit on connect and you will connect and that port will be given there for you. Okay. But now this is my question. What happens if you do something like this? I take that Ranger Web. This is how you'd be going to a website, right? You come over here, you put this information, Ranger Web, Cloud App, whatever, HTTP. This means we are going to port 80. And you know what? It will not go to port 80. This is a cached information that I have. So let's actually remove that so I can show you. Let me delete my cache. Otherwise, you'll be like, all right, Sean, you said it was going to not go anywhere. How did it end up there? Let's open a new browser. And I just realized that most likely I'm going to the Ranger Web Cloud App. It's taking me to Ranger VM001. This is actually showing something right. The reason behind that is if I go to Ranger VM001, I go to Endpoints, I already have a port 80 opened up here. And what I did in the backend for this demo was actually RDP to Ranger VM001, install a web server, and I actually have a web page that's being served right now, which says you're on Ranger VM001. Okay. The reason this is actually working, Ranger Web Cloud App, this stuff is working, is because I do have port 80, which I was demonstrating a little bit earlier with this. Okay. Let's delete this endpoint. I do not want any port 80 to go through. I did not want to go offline and fix this and come back because I wanted to show you what was really going on here. So let's remove this. And this time I'm going to go and I'm going to delete my all caches. Okay, the endpoint is deleted, so we do not have any port 80 that's open in either of these virtual machines. Okay, so let's go over here, close this browser. Let's try to go to the website. So that was HTTP whack Ranger Web. As you can see, the page cannot be displayed. Well, the page cannot be displayed is because I do not have any port 80 that's coming to the cloud service. So even though I have web servers actually installed on these both virtual machines, not going to work because, cloud service says I do not have any way to let it go through. Now, the web services are running on, or the web server is running on those both virtual machines. I've gone offline and installed and done all of that. So the question that comes to is that when we do this, when we go to HTTP, what port are we going to the web service? Well, we are going to go to port 80. So now the problem is that, okay, Sean, I know you have port 80. I want to go to port 80 on the Ranger VM1, which is fine. You will come over here, you'll go to add, you'll do this, you'll go and say, I need port HTTP. I'll keep everything standard. So I'm saying the public port is going to be 80, the private port is going to be 80 as well. Okay. Why are you not randomizing this public port? Well, the reason we are not randomizing it like the remote desktop port over here is because you cannot tell the whole world that you are going to be getting to our website with a non-default port. Could we have put something like 8080 over here or 8081 or a random port over here? Absolutely, we could have done that, but we can't tell the entire world that we are going to have our web server which is going to go to a different port. So rather than doing this, we can't tell people we'll be doing, for example, something like this, a random port number, because then people won't be able to go to your website because they won't know what the random port is. So the deal is that for this one, we need to keep port 80. This endpoint needs to be port 80, okay? And when they do 80, hit enter, you're on Ranger VM 001. That's because this port 80 is open on Ranger VM 001. It's not going to the web server over here. Now, the next question is, Sean, okay, so how do I do port 80 over here so it goes to Ranger VM 002? Because I might have something else over there. Well, you can't. You can't by design have two public port 80s forwarding to these virtual machines. Okay, you'll need a different cloud service. If you have a different web page that needs to come from Ranger VM 002, do not put them on the same cloud service. Because once it's a unique cloud service, the VIP changes, the URL over here will change to, this one is Ranger Web, that one will be something like, Ranger website or something else. You'll have to have Ranger VM 002 on a different cloud service to have a public port 80. So now comes the big question. Well, so why would we put two virtual machines in the same cloud service then? Okay, because it looks like that there's not a whole lot of benefit. Well, we can RDP to it, but there's not a whole lot of benefit putting them in the same cloud service otherwise. Well, this is a part that we have not discussed before and we are going to discuss today. I kept saying that you could put virtual machines in the same cloud service, but today we'll show why. So the reason you do that is for load balancing, okay? What we want to do is that we want to say, let's go back to the slide here. We want to say this virtual machine here will have the same website like this virtual machine over here. When this user connects to port 80, what we want to do is we'll still have port 80 on both of them, and I'll show you that we can't put port 80 on, for both this, but there's a way to do it. And when they come to port 80, it will get actually load balanced. So once it will hit on this server, once it will hit on this server, and it will randomly throw the connections to either of these virtual machines, and a load balancing will actually end up happening. Okay, so let's do that. Currently, there's no port 80. Okay, what we will do is add, and what we will do is that add a standalone endpoint. As you can see, the other option is even not there. So standalone endpoint. I know that this is going to be HTTP. I know that it's going to be protocol TCP, port 80 for public, port 80 for private. But what I'm going to do is I'm going to check this box over here, create a load balanced set. So in Azure, the load balancer is called a load balanced set because you keep a set of virtual machines in there. I'm going to click on next. It's going to ask me what's the load balance set name. This is a set name you can put by yourself. So make something sensible. I'll call it Ranger Web LB set. Okay, Ranger Web Load Balancing set. It's still going to be the pro protocol is going to be TCP. I'll get to this in a bit. Leave this alone for now, but that's just the load balancer set name, and click OK over here. Okay. So this will take a few seconds to actually happen. So let that happen. Okay, it took about 40 seconds for this to happen. But right now you can see that HTTP port 80 was created. You can see it's actually now in a load balanced set. So something over here showed up. And this is the load balance set name that we had. So okay, let's do the magic. Technically, we should not be able to put port 80 over here because port 80 is already taken for another virtual machine in the same cloud service. But watch this. I'm going to not add a standalone endpoint. Now I should have add an endpoint to an existing load balance set, and you can see that we have created this load balanced set over here. So I'm saying that go to the load balancing set and add this virtual machine over there. And there's not a whole lot that you can do over here because this is going to be port 80. You need to put a name, and the name is going to be HTTP. The reason they actually put the name over here is because you want to probably have a different name. I do not see a reason you cannot put HTTP over here because they are going to port 80 after all. And click OK. And all of a sudden, we can actually have two port 80s in this cloud service. The reason behind that is we are putting this in a load balanced set. So we are telling Azure that do not worry about distinguishing this port 80 traffic. We both are going to have port 80 because we'll probably serve the same content. Okay. And that's because I went to this virtual machine and created the web app server, the the IIS server, and in there I put two HTML files. So to distinguish which file I'm going to go to or which server I'm going to go to, I actually put different content there. In one of them, I have you're on Ranger VM 001. In Ranger VM 002, what I went and did is that you're on Ranger VM 002. Ideally, in your environment, it will be the same website. So what will happen is that you'll get load balanced. People, as far as your users are concerned, they won't know which server. They do not care which server they're going to because they do not care. But you do care, right? So you want to make sure that it's load balanced properly. So let's go over here and hit on refresh. You see, this time it threw me to you are on Ranger VM 002. So I know the load balancer is working right away because it's going to port 80. This time, for whatever reason, it put me to 002. Let's try again. If you refresh, it keeps sending me to 002 because it somehow became persistent over there. Okay, but right now the load balancer is perfectly working. If for some whatever reason Ranger VM 002 goes down, it will take me to Ranger VM 001. Let's actually demonstrate that. I'll come over here to the virtual machine and let's go to Ranger VM 001. And how do we do this? I do not want to completely turn this virtual machine off. What I'll do is let's actually connect to this virtual machine real quick. Okay, where I am on is Ranger VM 001. Okay, I'm on Ranger VM 001. So I told you that I installed IIS already, so I should have the management console here. And what I'm going to do is, as you can see, if I go to this one, it still takes me to Ranger VM 002. I think I wanted the other one, not Ranger VM 001. Did I? No worries. I am going to go to Ranger VM 2, connect, open. Okay, so I'm on Ranger VM 002 right now rather than 1. So I know, let's go back here. I know that I keep coming to Ranger VM 002. So I'll go to Ranger VM 002, go to IIS, and what I'm going to do is going to turn off the web server on 002. So if I turn off the web server for some reason on 002, here, let's come here, go stop. So I turn off the web server. So if users were coming to 002 at this point, they would be not receiving any page. It would be saying something like page cannot be displayed. But just because we are on load balancer, let's go and refresh this. You see, it changed to you are on Ranger VM 001. So the load balancer at the back end found out that for whatever reason, the web service or port 80 has gone down. And just because port 80 has gone down, it knows there is somebody else in the load balancing set with port 80, and we went to Ranger VM 001. Now, obviously, if you go to Ranger VM 001 and you end up turning off your web server here, you'll probably not get any page because there's nobody else to now serve to. Unless this is cached somewhere. Well, I know it's eventually going to fail because there's nobody. And it failed because now nobody is there to serve the web page. So let's go to Ranger VM 002, start the web server there, come over here, give it a couple of seconds. And you should see it showed up on Ranger VM 002 because now Ranger VM 002 has already been started. Okay. So what I'm trying to say over here basically is that now you know how to do load balancing on Azure because you have cloud service and you went and created two virtual machines in the same cloud service. You have opened up an endpoint which is in a load balanced set. So it goes and randomly puts you in these two virtual machines. I keep saying randomly, but actually it's not randomly. It does a calculation and brings up a hash with the connection information. And based on that connection information, it will keep throwing you with that hash on whichever virtual machine. So if I keep constantly hitting refresh over here, you'll see that I'm always on Ranger VM 002 because it's the same connection hash and that's what is happening. Now, if I give it a little bit time, I open up a new browser, I try opening a new connection, maybe it will throw me to Ranger VM 001. So there is some sort of a hash calculation that's happening to calculate which one the load balancer will throw you to. It's not like a DNS round robin or anything like that. So if you network guys, they're probably thinking that, why would it be random? And the reason it will not be completely random is because you need to have some sort of a persistence to do that. Okay, and that's what is happening over here. And now we know based on endpoints how we can load balance this. So I do have some information that I want to talk about the Azure load balancer. So the network level, it's a network level load balancing and it's for the incoming traffic, right? It's incoming traffic to different virtual machines of a cloud service. It's the same cloud service. And now the load balancing set needs to be created like we saw that you could not put port 80 as a standalone port on both the virtual machine endpoints because there will be conflict based on design on the cloud service. So what we are doing is we need to create that load balance set for this load balancing to happen. Just by manually putting two virtual machines inside a cloud service is not going to work. You have to have the load balancing set created for this to go through. Again, for the network guys, this works at layer 4. And the next point, like I mentioned, the VMs must be created as part of the same cloud service for the load balancing set to work. Okay, and endpoint names are what actually does the load balancing, right? So you have to have the same endpoint names. So for example, over here, if you remember, I went and I gave both of them the same HTTP name set over here. And it looks at that HTTP because of this port, and it finds out that I have to do this. And this is your load balancing set. Okay, this should be pretty straightforward right now. I am going to spend a couple of more minutes of your time to actually show you some things over here. So if I go get Azure VM service name and I do get Azure endpoint, so this is the commandlet I'm trying to show over here, you'll see that it will show you all the endpoints that are there on this virtual machine. And port 80, you can actually see there's a load balancing set name. The other ones, as you can see, does not have any load balancing set name because they are not there. This is the same information that you are viewing over here, but through PowerShell, and it's called Get Azure Endpoint. Now, when you are creating this virtual machine, you can obviously create an endpoint as well. So in your configuration file, new Azure VM config, you'll add Azure Endpoint. We're doing HTTP. we are doing a TCP port. This is the public port. This is the local port. So this is what you will do if you want to create a virtual machine already with port 80 built in. Okay. To an existing VM, it's very simple. You get the virtual machine object, get Azure VM, and again, you pipe it to add Azure endpoint. This is for an existing endpoint, okay? So if we wanted to do add Azure endpoint and we want to put HTTPS, which will be port 443, so we'll do the public port, local port. This is same like over here, public port, private port. Over here in PowerShell, we call it local port rather than the private port. And you do update Azure VM, and this will be good to go. Of course, you can also change the endpoint configuration of an existing VM. So for some reason, if you think the HTTP needs to be, rather than port 80, it needs to be 8080, then you can actually go and do set Azure endpoint, and it will actually do that. This was add Azure endpoint. This commandlet is set Azure endpoint. So this will actually go and change the HTTP port number. So you are basically just modifying it, right? And of course, as anything else, you should be able to remove it. The way you remove it is like pipe the VM object to remove Azure endpoint. So the ones you have to remember over here is get Azure endpoint, add Azure endpoint, set Azure endpoint, and remove Azure endpoints. Okay, those are the 4 commandlets that are used for operations. Do not worry about getting crazy about this scripts over here. I'll have it as part of this session. You should be able to download all the commandlets and scripts I'm going to show today for your benefit. But this is how you do it from the PowerShell. Okay. So now moving on, I did come over here something, and I told you that I'm going to discuss this later. So let's discuss this actually right now. If you go to add a port, I'll do like add a standalone port or what. Actually, you know what? Let's go delete this. Delete this HTTP port. It takes about 40 seconds or something to do any load this endpoint or load balancing operation. And the reason behind that is there is actually a load balancer in the cloud service. So it has to go and do all these configurations. Okay. So right now, Ranger VM 002 has that load balancing endpoint. Here, there is no load balancing endpoint. And the reason it's not there is because I want to create it again. So add to an existing endpoint, and we're going to put it part of this load balancer. HTTP. And you know what? I keep noticing that I cannot come to that point of the probes. So let's do reconfigure the load balancer. Okay, come over here. Yes, so this is where the probes are. I wanted to talk about this probes, that what this probe protocol, probe port, interval, and all this information is. Okay, let's go to our slide real quick. So let's talk about probes. What are probes? So you can have your load balancer set created with a probe. What this probe does is that it creates a TCP connection or HTTP based connection to the virtual machine port. So when you say my endpoint is going to be 80 on public and endpoint is going to be 80 on the private or the local port, the load balancer will keep sending a probe to your local virtual machines port 80 to see if it's alive or not. And the reason it does that is because the load balancer needs to know that he says that he wants to load balance port 80, but is his port 80 really up or not? And we noticed how this works, and the reason it's important. If you remember, we went to Ranger VM 002 and turned off the web server. What happened when we turned off the web server? Well, the port 80 went down. When port 80 went down, the load balancer looked at it right away and said that, hey, Ranger VM 002 does not have port 80 up again, so maybe I should not send traffic to Ranger VM 002. So I will send traffic to anybody else that's there as part of the load balancer, which was Ranger VM 001. That's why when we went to refresh the browser, it ended up going to Ranger VM 001 because the load balancer is at layer 4, and with the probes, it knows that this specific port is down. What happens is that without this port, it will keep still randomly sending you to Ranger VM 002, but whenever some users go to Ranger VM 001, they'll get through. And some users going to Ranger VM 002, depending on how the load balancer through them, they'll keep seeing that page cannot be displayed because the web server is down. That's why the probe is very important, because it will go and do a test based on the port number. Okay? Now, you might come and say, Well, Sean, not every server will be a web server. What if this was some sort of a different server serving on a different port? How do I, go and check that, my service is up and running and it should throw me to the second server or the first server where the, service is not down? Well, this probe cannot. Okay, this probe can, if you are serving a different kind of application which is not using any specific ports, it's not going to work. The only way this port works is if you have a port that will be up and running, because the probe goes to the specific port to check if this port is up or running or not. So for our case, when we turned off the web server, port 80 went down. If you have another application that's serving on port number 8080 or something like that, if we put that port number, it will send the probe. The probe can only access the port number. Now, Azure was not happy with this answer. Azure was like, no, there are people who are going to do a lot of other things, right? And they could be load balancing a bunch of stuff in the cloud service, and they might not always necessarily have a port. How do you deal with that? So they came up with something called as the HTTP probe. I'll explain why HTTP probe the name is a little confusing, but why it works. What it will do is that it will, if you create an HTTP port, it will go to your web server or it will go to your virtual machine and try to hit healthcheck.aspx, for example, this path, and see if this page is up or running or not. So you will get an HTTP 200 OK code back if it's successful. So how does that help with something like a database server, right? Well, what you can do is that you can create an ASPX page, some coding is involved, and it will try to go and, for example, connect to a database server. Okay? Your web page will try to connect to a database server. If it cannot go to the database server, means that service is down, you'll have the code not send HTTP 200. It will send something random. So that means you are still having the probe go to a port 80, for example, where this HTTP will be, but now you are programmatically not looking at just the page. You are looking at something else that's happening on the back end. So for example, this health check will open up a database connection or Active Directory connection. And if it cannot make that connection, it will not reply with the 200. It will reply with something else. And the probe will know, hey, wait a minute, I did not get HTTP 200 from the healthcheck.aspx page, means something must be wrong. Do not send traffic to this server. I think this is amazing because you know what? With this ASPX page, you could have like crazy kind of logic that could be done. Like you could go and check, hey, is the Active Directory up? Hey, is the SQL Server up? Because hey, is the SharePoint up or my Exchange server up? You could do crazy things programmatically and still reply to that probe with something very simple to see if it should serve people in that load balancer set to that virtual machine or not. Okay, so this is very unique. And that's what probes are used for. Now, the way this probe test works is that by 15 seconds default, if there are two failures, so each 50, so the first time it will hit it 15 second and it will be like, not working. I'll wait another 15 seconds. It waits another 15 seconds and sends a probe again and says, not working. So 30 seconds have passed. There are two failures. It will be like, okay, this virtual machine or this node is no longer or should no longer be serving. Now, if you looked at what we were doing, I think it took 30 seconds. I felt that it was a little bit more quicker than 30 seconds to actually find out that my virtual machine web server was off. But that's what Microsoft documentation says, two failures in 15 seconds. So you should think that for about 30 seconds, people may have the page cannot be displayed. Even though I found out that it was almost instantaneously, it took over. So, but the probe test says that's what it is, okay? And these all can be configured from here. So you can actually change that. You can see that the probe port is 80 and probe interval was 15 seconds, and you are going to have two probes that will be sent, okay? This is by standard. If you do not want the TCP, this is the other probe, the HTTP I was mentioning. So it's going to still have the same timing, but you are going to give a probe path. So my probe path was what? Healthcheck.aspx. So yeah, you'd be having healthcheck.aspx over here. Okay. That's because I went and told my web server that healthcheck.aspx is going to do something. You could have any other name over here. Chances are most of the time you'll probably have TCP port over here. Okay. And if you do stuff with System Center, Microsoft's product System Center, configuration manager and stuff like that, you probably, or I mean, operations manager, SCOM, then you'll know that this health check is not a new concept. You could do that in there as well. So for Microsoft guys, this is perfect. Azure can do the same thing over here. So that's what probes do. Okay. I do have some. I do have some probe related, and I am looking for that. There you go. Almost forgot to put it there. Okay, so let's do this so you can see better. So I have to do a couple of PowerShells that go with this. So get the virtual machine and you can do add Azure Endpoint. We know this. So what we are doing is we are going to go and put it in a load balancing set, which is this one. And in the load balancing set, we are going to go put this probe information in there as well. So it's add Azure endpoint. It's still part of add Azure endpoint to put it in a load balancer. Okay. The only thing that puts it in a load balancer is the -lb setname. As long as you do -lb setname, it will go and do that. If it cannot find the load balancer setname, it will create that for you. Okay. And in the load balancer setname, obviously, since you're putting this in load balancer set, you have to put the protocol for the probes. You're going to put that protocol in the probe. So load balancer set always needs this information. It's part of add Azure endpoint. And to change set the probe on an existing load balancer. So for example, we are trying to put the HTTP protocol. So you can put over here HTTP LB, and the protocol is going to be protocol HTTP. I'm sorry, this one should be over here, protocol TCP. So protocol HTTP. So I'm saying that the probe protocol is going to be HTTP. It's going to be port 80 always, and this is the probe path. So this is set as your load balancing endpoint. So we are dealing or modifying or adding something on the load balancer itself. So it's load balancing endpoint. Because remember, endpoints can be single endpoints or load balancing endpoints, okay? So don't worry about this PowerShell copying it down. It will be part of the script, but this is how you do that. And that's all about the information I want to spend on the load balancer over here. At this point, you're good to go, okay? We are pretty much done with this session because I've talked about the endpoints, I talked about the probes, and most importantly, I've talked about the load balancer set. So now this will give you a better picture on why two virtual machines should be in the same cloud service. Well, among many things, we can load balance them. That's why they should be in the same cloud service. Can you load balance two virtual machines which are part of separate cloud service in Azure? No, by default, you cannot. You'll have to use some sort of a appliance, some sort of stuff from your end to load balance them. But if you want them to load balance by Azure, they need to be on the cloud service. Now, the next topic, I'm going to very, very briefly touch this for your exam. If you're not studying for your exam, you probably do not need this because there are other ways to do this. But if you're going to study for your exam, the next topic is important. It's almost becoming deprecated, so it might not be there in the future, but they are still there, and it's their part of your exam requirement, so I'm going to go with that. That is ACL, or which is Access Control List. So let's talk about this because this is important for your exam. ACLs or access control list. Networking guys, Cisco and Juniper, all these guys, you guys know ACL very well, that what access control lists do. Access control list actually controls access, right? I mean, it provides the ability to selectively permit or deny some sort of a traffic to an endpoint on our virtual machine. So for example, I'm allowing the entire world right now go to port 80 with that little endpoint that we had created. What if we do not want to do that? Well, I do not see a reason you'll ever want to do that. You probably want the whole world. So port 80 is probably a bad example. Let's think about the RDP port, okay? As you know, the only way to access RDP is from the internet. There's no way you have a console sort of thing where you can go and look at the virtual machine. So you have to enable RDP. And a lot of organizations were not comfortable with enabling RDP on their virtual machines or on their servers, because they're like, I do not want the entire world to RDP into it. I will have my people go onto the virtualization platform like Hyper-V or VMware and go to the console directly, or have something else proprietary to do remote management, but not allow port 3389 to do that. Well, in Azure, you cannot do that. You need your RDP port to be up and running. So what you can do is you can create an ACL. With that ACL, you say, I'm going to deny everybody to the RDP port, except my IP address or my subnet from my organization to go in. So by default, you have now blocked everybody to go in there except your people. That's what ACLs are good for, allowing a certain set of traffic to come in or denying a set of current traffic to come in. Okay? ACLs are only effective, and this is why it's becoming deprecated. ACLs are only effective if they're on a virtual machine and not on a virtual network. You and I both know that in a production, you will rarely be doing what I just did. I do not have a virtual network created. For most of my demos, except when we were doing virtual network, I did not put things on virtual network because I did not have to. But in a production, I can assure you 99% of your time for infrastructure as a service, you will have a virtual network. And with that virtual network, you are going to build on it all your virtual machines and have all the IP address and everything accounted for, not something random like we did in our demo over here. So if you cannot use ACLs with a virtual machine that's on a VNet, then what's the use? Well, not a whole lot of use, right? So chances are you'll not be using ACLs a whole lot, and that's why this is I mentioned if your production guys came here to learn something, you could probably stop at this point. But for your exam guys, you need this. And the other thing is that for virtual machines in VNet, they use something NSG. So it's the network security groups. So there's something else that does similar thing when you are on a virtual network, right? And we'll cover this in a much future session sometime. But there are stuff that will allow you to do this when you are on a VNet in production. But otherwise, ACLs are not effective on this. Okay? When you create a virtual machine, you might say that I do not go and do this ACL business. So how is this all happening? Well, in the back end, ACL has already been used multiple times every single time you created a virtual machine. Azure just went and did that for you. When a VM is created in Azure, it creates a default ACL that blocks every single traffic. You are not allowed to even go and do anything on the virtual machine. You remember those two endpoints that got created, PowerShell and RDP? Well, what happened was that when you create that endpoint, or when Azure actually goes and creates those endpoints for you, it goes and modifies the ACL to allow that PowerShell and RDP traffic. Okay, so if we go to our client machine real quick, I want to show you this over here, is that when you went and by default, these two endpoints are always created for you. So when initially this virtual machine was created, the ACL was created. But when Azure was creating or provisioning these two endpoints for you, it went and modified the ACL for you to do that. So you might say, okay, Sean, you just went and did HTTP port, and I did not recall you doing any ACL. Well, when we created the HTTP port, it went and also modified the ACL to allow all traffic to port 80. Okay, so anytime you create an endpoint, the ACL gets modified to allow all traffic to those ports. So for example, in Ranger VM002, just because we have port 80 over here, by default, Azure goes and enables port 80. That's one thing. And after enabling port 80, it goes and says that, hey, I want all traffic to be allowed to port 80 by default. So every time you are doing this endpoint stuff, ACL gets, rules are getting created and modified and things like that, okay? Let's go back to our slide. And the last point I mentioned is that it's going to be deprecated soon by network security groups capability completely. I'm assuming that Microsoft is going to find one of these days that it needs to deal with only virtual machines, not on the VNet in a very specific way. I do not know how they're planning to do that, but they are planning to do that. So, but still, it's an important thing, part of your exam, so you need to learn what ACLs are. And there might be some rare situations where you might use it, right? You might come and say, hey, Sean, you know what? I just need to I'm a small business. I have a 2-page website. I do not need to be on a network. The stuff that you just did over here with this, it was more than enough for me. As long as they hit one of the servers or whatever, hit this one server, I do not care. Well, you know what? You might be one of those organizations, a startup, who just needs some sort of a single page web page or something. So there are applications or need for applications. I just do not see it being very powerful in most production environment. Okay. So the way you deal with ACLs is you can see there's manage ACL over here. So by default, as you can see, there's nothing on this endpoint. Okay. Because when you have nothing on this endpoints means you're permitting everybody in there. Now you could come and say over here that I'm not going to allow. So for example, let's see, let me get hold of an example real quick for you. Okay, let's come over here. So let's create, I've got something for you here. So let's create an ACL which will block, I don't know, some competitor. Okay, for some reason we figured out what their remote subnet is, and this is going to be a subnet, right? So you have to remember, so I found 694.696.100, whatever, port 24. This is actually quite a large. Don't do anything like this, okay? I mean, your networking guys are probably like going crazy right now thinking that this is a quite large, uh, quite large domain, okay? So, I mean, quite a large number of public addresses. But yeah, this is what you do. It has to be a CEDAR notation. So you have to put a remote subnet over here. And I'm saying that I'm going to deny this. And remember this order number over here, okay? Because this order is important. Right now, we only have one. So I'm going to click OK over here. It takes like a few seconds, about 30 to 40 seconds. Yep, that took about 30 seconds or so. So right now we have an ACL that's on this HTTP. So if you go to edit, sorry, if you go to manage ACL over here, you'll see that we actually have some ACL over here. And this access control list is saying that do not allow any people to come from this um, subnet. And it's a public subnet, right? So this is quite a large subnet. So this is how you'd add them. Or you could say over here, permit, allow my company traffic. And you could also have done this. So what will happen is it will only allow these people from coming from your company's subnet to this IP address. You probably want to do that for the remote desktops, right? You want to have only your company subnet allowed to connect to your remote desktop publicly. So that means everybody who's in the office will be able to connect that. Anywhere else in the world, they will not be able to do that. Okay, so that's one reason you probably want to do that on your remote desktop. And that's basically it. You can add more to your ACLs, obviously. Right now, obviously, it's updating it, so it's not giving us that option. But what's going to happen is that you can add multiple entries or multiple entries with permits and deny on the same with the same endpoint. But what you have to remember is that if we come over here, you have to remember that the order number, okay? So this order is the most important, and as you keep going down, they have the significance of the order changes. So whatever you have on the topmost over here will have the highest priority, right? So you have to be very careful if you have more than 5, 6 different rules over here, because you might miss one of the rule and it might not work as effectively as you think. If you are already used to doing Cisco ACLs or Juniper ACLs, you know exactly what I'm talking about, because you could have like 5 different rules over here and they might overlap so much that you may not be able to figure out which one is the one blocking you. So this requires some little bit of a planning to figure out what do you want to do here and how do you want to block or allow traffic. Do remember, from the exam point of view, this order number is important at what order you are, your rules are. Now, to bring this about completely, we have to remember how to do this in PowerShell. Okay, so the way you do this in PowerShell is that first you need to create an ACL object. So this is the command that you will use, new Azure ACL config, and you're going to put this in ACL. Now set as your ACL config, this is where you'll add a rule or remove a rule or do whatever. So this is add rule. I'm saying that have this ACL object, okay? So this ACL object is, we are going to add a rule to this ACL object. Order of 100, for example. My action is deny a remote subnet, this one with a description, okay? So this is one thing we can do. Then this was a denied rule. I want to do a permit rule. So I'm saying add ACL rule, order 200. So deny these people, then permit these people. Okay. and we are going to allow this guy, and we're going to call this a permit rule. Now, once your rules are ready in your ACL object, we are going to get the VM, so VM object. So for our case, Ranger VM001 was our VM, and it was in Ranger Web. The way you do this is that you set the Azure endpoint. So this Azure endpoint was already there. So you set the Azure endpoint and you say that the port number, for example, 5986, add this access control list over here. And then you update the Azure, okay? So let me just create, we do not have something called as 5986. So let me create a 5986 on the Ranger VM over here. Actually, the 5986 was your PowerShell port, right? So it should already be there. So I'm actually controlling the traffic that's going to be on the PowerShell port. Right now, there is no rule. So what we are going to do is come over here. I'm going to allow some traffic and I'm going to deny some traffic. As soon as you do that, you can see that it has displayed some information here. So the information was that the rule ID is 0 for this one. And what I said was that I need to deny this ports. So it's denying, this subnet. And then my rule ID 1, I'm saying that I'm going to permit, and this was the order 200, right? The order 200, rule ID 1, I'm going to allow some traffic or to permit some traffic, okay? So right now it's not done. So I have not run the whole thing. Now let's actually go and apply that. We are applying this on Ranger VM 001. We're doing set Azure endpoint. When do we do set? We do set Azure endpoint when the configuration on an existing VM. So this VM was already there, the port 5389 was there. So we are using set Azure endpoint to modify the endpoint configuration. Okay, so let that happen. Okay, that took about 30 seconds, and we can see that it has succeeded in doing update Azure. Okay, so Ranger VM 001 right now should have these two rules. So let's come over here, Ranger VM 001 PowerShell, manage ACL. And as you can see, these two rules showed up. The first rule was deny. So the rule order ID was 0. So this one was 0. So this was deny, which was order 100. So it's over here, it's deny. And the second one was permit. Now, remember for your exam, and even if you are doing this in production, this order is very important, okay? What happened here? The reason we did deny first is because we want to deny it first before we permit. If we had this permit rule first, what would have happened? While we are permitting this rule, only for this subnet, nothing is blocking this subnet from getting through, right? So if you had the permit rule first, even though you are not, even if you're not, if you're putting in a specific subnet, even if you're doing that, you'll notice that this one will still get through. So you want to make sure that the denying is done first, then something explicitly allowed. So ideally, you want to have all the deny rules first to make sure that people are denied first, which is everybody, or which is this specific people, then the permit rules are done. And as I mentioned, that as you keep going down, it loses precedence, right? So your rule order 0 has the highest priority. As you keep going down, it will go in this sequence. So first it will go deny this guy. So we know he is not allowed. Because by default, everybody's allowed first. So we have to deny him explicitly first. And then you explicitly allow these people. So there is another rule before this that you are not saying, which is allow everybody, right? So that allow everybody is now all the way down. So what happens is that you denied it, you permitted it, and that's all that's there to it. So this endpoint will only work on this two. And this is how you do it in PowerShell. And this is there for your exams. You have to remember that for your exams. I will put this script all together and make one large file and leave it over there so you can actually take this and practice. Okay. So I guess that's all we have for this session. We are pretty much done with this. We have covered endpoints, what endpoints are. We have created endpoints both on the management portal as well as we have done that on our PowerShell. We have found out that how you can put two virtual machines in a cloud service and use something called as load balancing set or load balancer set or Azure load balancer to load balance traffic. We have looked at how probes can be used to find out that which of your load balancing set nodes are up and running or not. And in the end, we have used ACL on the endpoint to actually allow specific traffic or deny specific traffic. So we have come around all 360 degrees to everything related to Azure VM endpoints. Extremely important for your exams, extremely important for some of the stuff in your production. For example, we use load balancing set quite often for load balancing web servers. So that's all for today, guys. As usual, training site is at cloudranger.net/Azure training. And on YouTube, you are viewing us at Cloud Ranger Network. I'm at Cloud Ranger blog on Twitter. And you can email me at sean@cloudrangernet.net. Okay. I just want to wrap up a couple of other things before we completely shut down. Some people have queried on email as well as on the comments requesting a specific traffic, not traffic, requesting a specific, I'm talking so much about requesting traffics, requesting specific sessions. And I am following currently Microsoft official curriculum sequence, sort of. So there's a reason these topics are happening before we are moving on to the next traffic. It's not like something random I'm picking up and saying that, okay, let's go and do Azure Endpoints today. No, these are introduced in a certain sequence to make sure that your next sessions are more effective. I will not be able to do something super serious like a web services in Azure or something like SQL services on Azure Active Directory or anything like that till you actually know how a cloud service works, for example, or till you know how the networking works, for example. So Microsoft has built that sequence, and which I agree to, and I have showed in one of my previous sessions that you can actually go Bing this information or Google this information and find out what this Microsoft official curriculum is, and you can see that I'm following the same sequence. And the reason behind that is for effectiveness and nothing else. It's not something that I pick up, okay? Will your request be taken into consideration? Absolutely. I will cover every single topic that's there part of this exam. I'm trying to actually catch up on a lot of things. So I used to have 2 or 3 sessions every week, which I have not been able to, and I'm sorry for that, but I'm trying to get back to that from this week. So you will actually see another video up and running very soon, sometime this week, or, I do not know, maybe today if I have the time. But I'm going to be a little bit more rapid in releasing these videos, okay? So as usual, leave comments on videos or email me, or if you have any other questions, you can ask. So I understand that you're understanding this stuff well, or if you have any other requests or you need to talk about everything else. Okay. All right. Thank you for viewing, and I will be seeing you in my next session. Bye.